So from today onwards, we will start the various section, right? And today I'll cover basically the nuts and bolts of R. And here I'll give you a basic feature about entering inputs, then evaluation, how we can evaluate two numbers, how we can do mathematical operations or relational operations. Here I also give you the claims how we can write the variable name or object name, right? Then we'll see how many objects we have in R, right? So basically there are five type of atomic objects. Okay, I'll describe all, and then I'll also show you the numbers, how R treats a number. For example, in case of NAs, numeric NAs or character NAs, how it handles. Sometimes we also have a definition of minus infinity, plus infinity, right? Those were not there in other programming language, but here in R we have minus infinity and plus infinity. These two are a defined term. We also have one another thing that is called not a number. So whenever we have a chance, right, whenever we have a mathematical equation that is in the form of 0 by 0, right, that is not elegant form, right, we cannot evaluate that part. Okay, but we have that representation here in R in the form of NaN, that is called not a number. Then I'll show you the attributes. Attributes are basically a metadata about objects. Okay, and then we'll show you how to create vectors. We can create vectors in multiple ways. I'll show you using concatenate operator or combine operator C, and we also have a function vector that can help in creating a dummy vector, right? Dummy vector basically you can create a numeric dummy vector where you'll just have to have a 0, right, as an element. In case of character vector, you will have blank. Similarly, you can create a complex and other type of a dummy vector. I'll show you those. These are very essential because sometimes we'll have to do some kinds of evaluations, some kinds of mathematical operation, and we'll have to store the values right in the vector. So that's why we'll have to create a dummy vector at the very end, at the very beginning, and then we'll store the result into that dummy vector. Okay, and then we'll have a question answer session at the end. So if you have any burning question at any time, right, you can just stop me. I'll happy to be. Okay, so let me open my RStudio, and here we have. Okay, so first of all, this is class number 5th. Okay, and here, yeah, I already showed how to remove an object. So for example, let me show you. Here we have various objects. Suppose I need to remove this ADSL. Say, so what I can do, I can use RM function. This function basically remove any objects from this R environment. This is basically R environment. You can think of a working directory, right, similar to working directory what we have in SAS. Okay, so what we have to do, we just have to use RM function, and whatever the object that you want to remove, we just have to put inside this parenthesis, right? So if I run this, it will basically remove ADSL from this global environment. Okay, so ADSL is not there, but this is not efficient way because it will basically remove objects one by one. So what we can do, we can use this ls function. What this ls function does, it will basically fetch all the objects that are present in the current RStudio session or R environment. So if I run this ls, it will basically extract all the objects. So ADLB, ADSL1, CHAR, these are basically values or numeric vector or character vector. Okay, so this CHAR, this is character vector or a string. Num is an integer vector. Then num1, this is a numeric vector of size 1, right? PKC is again a character vector. So here we have different kinds of element, right? So what I'll do, I'll utilize this functionality of ls and list, right? Because list can store a multiple type of data type. Okay, so here we are just extracting all the objects using this ls function, and then I'm storing here in list. Okay, why list? Because list can store a different kinds of or different data type of objects, right? And then we are running a rm function on top of that just to remove all this in one go. Yeah, so if I run this, it will basically kill everything, right? And this is similar to kill option what we have in SAS, right? So this is the basic step. So whenever you are starting any session, right, in RStudio or R, try to clean, because I don't want you people to do overwriting on objects that is already there, right? So you can just clean and then you'll set the working directory. So first of all, before setting the working directory, we can extract the working directory location, right? I can run this, and by default it will basically points here in C drive. Okay, and then you can set to other drive location. Okay, so because I don't want to set in C drive, but here in the system currently I just have a single drive, right? So I don't have any other option. No, we have. So I can set here in D drive. Okay, I can set in September folder. So I can copy these locations, and then I can basically write this location here. Yeah, and then I can just, so R does not recognize a single backward slash, so I just have to either make it double, right, double backward slash, or I have to use a single forward slash, right? So if I run this, it will basically work and there is no issue. You can very easily check, right? And here, this is the location now it is pointing. So benefit of setting the working directory is, if we have any files that is located at this location, you can very easily import without specifying the path. Okay, this is one advantage. So the second advantage is, if you store anything, right, it will basically store as a default at this location, right? So these are the advantages of a setting of a working directory. Then we can also do a setting. We can also do right, setting of working directory with a single forward slash. Right, you just have to change the location. So let me just use some other location other than this so that we can verify. Okay, so now I'll set here in the output folder. So I can copy this location and then I can replace that. Okay, and then I'll do a replacement in one go. So I can select this, or I can select this whole line, and then I can use Control F. And what I want to replace this single backward slash. So I just specify here single backward slash, and then I replace with a forward. So I can just replace. Let me select this in selection so that it can only do the replacement at this line number 10, right? And now I can replace one by one. So whenever you are using that option, try to use replacement, not replaceable. So because it can replace any other location, right? And I also have to use at the end. Why? Because this output is a folder. I just want to store. I want to specify this working directory location right inside this output, right? So that's why I'll have to specify one forward slash right at the output. Okay, so if I run this, it will basically set, and I can verify using get WT option, right? And here, this is the location. So you can notice the difference. Earlier I used just September 2024, right? And now I set the working directory inside that folder. And whenever you're doing a multiple setting of working directory, what this does, it will basically replace the older one, right? And it uses the latest statement, right? Or latest location. Okay, so then again here, this is just to showcase this does not recognize the single backward slash. So you can verify that this output is this location is not correct. So I can just place this location. Let me use that. I can go one step back, and here I can just copy this location, because right now I don't have this folder right in this laptop, because earlier I was using the different laptop. Okay, so this is the thing. Here we just have single backward slash. It should not recognize, right? So maybe I can just verify that. Yeah, here you can notice we are getting error message that this backslash is unrecognized escape character. Why? Because this backslash is used in other nomenclature. For example, putting an extra line, right? So backslash n, I'll show you later. Then backslash t, just to specify tab space, right, between two texts. Okay, so that's why you cannot use here in the setting of working directory. Okay, so I'll pause here. Any question on this setting of working directory?
Ranjit, what's the difference between a setting and then get WT?
Yeah, setting means you're just setting the working directory, specifying, giving information to R, right, about the working about a placeholder where it store all the object, right, and also you can very easily import from that location, right, if you want to import any files. Getting means you are just verifying that whether that is set correctly or not. Okay, so get WD, it will basically extract the working directory location that is set previously.
Okay, it is similar to libname.
Yeah, so here this is similar to libname statement of SAS. Yeah.
Okay, thank you.
Okay, anybody? Any follow-up question, anything? Okay. So now I'll move to the next part, and then here nomenclature of our variables. So first thing is we should have a very meaningful and short variable name, right? This is very general rule, right? But I'll describe here some other. Okay, so a valid variable name consists of combination of alphabets, number, dot, underscore character, right? So the difference, if you compare the difference with SAS, here we have additional thing. Here we can use dot, right, in the variable name or in the function name. The same rule applies for the function name as well, right, or data set name as well. So here we have extra. We can use a dot or period in the variable name. For example, var dot one underscore, this is a valid variable name. Similarly, var underscore one, this is also a valid variable name. Var dot one, this is valid variable name. Var dot test, this is also a valid variable name. Okay. Apart from the dot and underscore, no other special character is allowed. So this is kind of some additional part, right, that is added. So we cannot use maybe a dollar symbol as a variable name. So where dollar symbol a or where a point or hash one are not valid variable name. These are invalid. Similarly, where underscore at the rate one, right, or at one is not a valid variable name. Similarly, where tilde is also not a very valid variable name. Okay, so variable can start with alphabets or dot character. Okay, but you cannot start with the number. That is a difference again with the SAS. In SAS, we can have variable with two underscore or underscore, but here we cannot have. So variable can only start with either alphabets or dot character. We cannot start with the variable with number. We cannot start variable with the underscore. Okay, so the variable should not start with number or underscore. This is the difference with SAS, right? And here, for example, to var or underscore var is invalid variable name. So whenever you are converting the data, right, from SAS to R, and whenever you have variable with named underscore, right, or dot or maybe underscore or maybe number starting with a number, so what you can do, you can just combine some additional text, right, prior to that variable name, so that it will not create a problem. Okay, so this is one suggestion. And if the variable starts with a dot, the next thing after dot cannot be a number, right? For example, dot 3 is invalid variable name. Dot 4 char, this is also invalid variable name. But dot char, this is valid variable because after dot we have the character, we don't have the number here. Okay, so the exception is we can have dot or period in the variable name, right? This is okay, but we cannot use other special character other than a period or dot or underscore. Okay, then the second is we cannot have variable name that start with number or underscore. Okay, and the third is, yeah, after the dot we can only have character in the variable name, right? If you have dot and then you'll have number, that is not a valid variable name. So you'll have to just keep these things in mind, right? And don't remember, try to use, right? Because R can provide a flexibility. If you write the variable name, that is okay, right? It can accommodate in a different way. You'll have to use tick symbol at the beginning or at the end. Okay, but I recommend try to use a meaningful variable name, right? And you can use these rules, right, for defining the variable name. And other thing is you should keep the variable name short and meaningful. Okay, for example, I am storing here a few names, so I can specify the variable name as name, right? And then I can store the values. For example, I want to store a single name, and maybe I can store RAM here. Yeah, so this is single name, and if you notice, this is the element, and here we have a variable name. Okay, so this is the way of storing single name. Suppose I want to combine here multiple names, so what I can do, I can use combine operator, C at the very beginning, yeah, and then I can use the opening of parentheses, and here I can combine multiple name one by one. For example, I can add here Bhargav, then Anvita, Riaz, yeah, then yeah. So I'm just stopping here, sorry for that. So here what I did, I just specified all name one by one. You can use here single quote, double quote, right? And you'll have to separate one name from other by a separator as a space. Sorry, a comma. Okay, so here we just have to use a comma as a separator. Okay, and then I can run, and now it will update. If you notice, earlier we just have a single name, but now here we have a 6 name, and this is the data type. CHAR is a data type, and this is an indication that this name variable has 6 different names. Okay, then here you can also create the vector of age. I'm just using here a dummy list. Here also we have 6 number, but the difference is in the name vector, this name object, right? So object is what? You can combine the element with the variable name, and that is called object. Okay, and single, just if you try to indicate this name as a singleton part, right? So that is called a variable name or column name or a vector name, because this is a vector. Why? Because here we have the specification 1 colon 6. That means it has 6 element. Okay, and all 6 element is of character data type, so that's why we call a vector. Okay, so if you combine the element with the variable name, that is called object, right? So when I'm calling object, I'm referring the variable name along with the element. When I'm calling variable, so I'm just referring the name, right? The name here, then again age here. Okay, then again we can basically check the data type of an object or a variable. Okay, so here you just have to use str, and you can very easily check. It is already there, but this is a formal way of verifying that. Okay, so you can use str. Str is a short notation for structure. It will basically provide us the structure or data type of an object. So if you notice here, it is giving char. This is short notation for character. Yeah, and here we have element 1 colon 6. That means we have 6 element. You can count 1, 2, 3, 4, 5, and 1 is shown here. That's why we have 6. Okay, then you can also check the structure for age. Age is a number, right? So that's why it is giving num here, and we have 6 values. So this is the difference between two. So one is a numeric vector, the other is a character vector. Okay, I'll pause here. Any question? Anybody?
Hi, Ranjit.
Yeah, please.
Could you please repeat the difference between object, element, and vector separately? Like, like for example, rows variables are vector, for example. So
Yeah.
data
values are called element. For example, here, let me just write. Elements are nothing but the data values. Data points or values. Okay, for example, yeah, easy here. You can have RAM, Bargo. Yeah, similarly, you can have a 34, 32. These are called element, right? This is one thing. Then we have other things. So if we have and yeah, so this name is called a variable name. So variable name or column name, this is basically a name and age, right? So here what I'm doing, I'm just storing this number, right? I'm specifying this number, I'm storing and inside this variable name age, right? So age is called variable name or column name, right? Then second thing is we can have object. That object is what? If we combine variable name and element together.
So here in R programming, we call them as vectors, right?
Yeah, vector is different thing. Give me a second. Yeah, when you combine a variable name and element. So this is called object, right? Next is what is vector? Any object what you create in R, that is a vector. For example, let me do that. Here I write name 1, right? And here I'll give a single
Ranjit.
name.
So Ranjit, let me pause. So object means just assign one element.
Give me a second. I'll just explain and then you can ask me. Okay.
Yeah.
Give me a second. Yeah. So for example, I'm creating additional object, name 1 that holds double A, right? So if you notice, this is a singleton element, right? This is also a kind of a vector. Okay. So here is dot vector. Yeah, if you notice, is.vector is a function that basically checks whether a particular object is vector or not, right? So if you create even a singleton element, if you create in R a single element, right, that is also a vector, because this is a speciality and this is the way how it stores. Okay, in case of multiple, for example, I can combine here multiple things, right? Multiple names, for example, BB, then CC, then DD, right? So here we can get an idea very easily. Why? Because we have a number, right? Index assigned. For example, if you notice name 1, here we have index 1 colon 4, right? That means we have 4 objects. This is very clear, but in case of single, it will not provide that. Okay, but you can use this explicit function is.vector and it will provide here answer as true. That means this name 1 is a vector. So vector is what? If you create any element, right, of a similar kind in R, that is stored as a vector. You can have numeric vector. For example, age, this is a numeric vector because the number is stored as a numeric, right, integer. Similarly, here we have a character vector because names are stored as a character. Here also, this is name 1 is again a character vector because these values are stored as a character. Why? Because we have a quotation here. Okay, yeah. Hope this makes sense.
So now again, name, age, name 1. These 3 are vectors.
Yeah, these 3 are vector.
So combination of vectors are objects.
No, you can this names, this name, if you're calling names, right, and if you're also including this whole element, right, so this is called a vector, right, because inside that we have multiple elements of a similar kind, right? So when we have more element of a same kind, then you can call that as a vector, right? There is a difference between objects and vector. So in case of vector, you are not detailing, you are not going depth about the data type, right? So vector basically holds a same kinds of data, right? In case of objects, so this is basically combination of a variable name along with the element, right? So if you are combined, why? Because this is conceptually, right? So here maybe I can take a screenshot and I can show you here. For example, inside the memory, right? So for example, here we have all the memory of R, right? Here we should have different names. For example, we have names here. How many names? Yeah, for example, we have 4 names. AA. Okay, I'm just writing with a mouse. BB, CC, right? And then we have DD. So whenever I am doing this assignment, name 1, Yeah. So what I'm doing, we have a memory where we have all the elements stored, A, B, B, C, C, D, D, right? And whenever I'm just assigning this with the operator, this left signed operator, what we are doing, we are just mapping, we are establishing the linkages, right? And whenever you are establishing the linkages, the combination of this variable name and the element, sometimes variable name are also called as symbols. So when you combine symbols with the element, that is called object. Vector, when we are referring this whole thing, and when we are concerned about the data type, right? The data type of these elements, okay, that is called vector. Element, these are all the thing that is stored inside that particular column name or particular vector, that is called a element. So hope this makes sense. Any question?
I still didn't get the object.
So object is basically whenever you are combining the variable names with the element. Simple.
I mean, just show us one example.
This is the example here. For example, when I'm referring this four names A, B, B, C, C, D, D, right, along with this variable name, right? Whenever I'm calling name one as an object, so I'm referring this variable name along with this four. Okay.
Oh, yeah. Okay.
Yeah.
Okay. The whole equation we call as object.
Correct. Element. These are individual elements.
And what is this is dot? What does that refer to? Is dot.
This is the function. This function is used to check whether a particular object is vector or not. This is called is dot. So you are just asking a question whether the particular maybe age or anything is vector or not. And if you get, it'll get answer in the form of true and false, right? And it will basically, if we are getting answer as true, that means that object that you're passing inside this parenthesis is vector. Otherwise, that is you'll get false. So in that case, the object that you're passing is not a vector.
Okay, got it. Yeah.
Sir, I have a question. So let's say name one have only one element, then also it will be a vector.
Yeah.
right?
Yeah. Then also it will be a vector. I also already checked, right? So earlier we would just have double A, right? And I checked that here. For example, if you notice, I checked that and it was giving true.
Ranjit, object can be defined as a data set, right?
No. Data set is not our object. Yeah. Data set is not. Data set here in R we call a data frame, where we have columns and where we have rows. So rows are referring observation number and columns are basically variables. I'll come to that point.
But as we can see in that object, if you combine variable and elements, it's called as an object. Can we call this object?
No, we cannot. So we can call object, but this is not a data frame. This is not a data set, right? We call here a vector.
Yes.
You can call a vector, that is a proper nomenclature, or you can call an object, but you cannot call a data sets or any data frame or anything.
So object we can refer to as column.
No, column. You cannot refer columns. So objects are basically combination of a variable name and the element, right? That's all. Don't mix up these.
I think 36. I think row number 36. It's called the object, right?
Correct. So this is called object, or maybe 37. This is also called object. This is also object.
Right.
Why? Because whenever you're calling objects, that means you are referring the variable name or column name along with the element, right? Whenever you are calling vector, you're just mainly focusing about the variable along with their element, and those elements are of a same data kind. Okay. For example, the vector can be an object, but other way. But in opposite is not true. Okay. So this is all. I'll just come to that point again, I guess maybe at the bottom, or maybe tomorrow. What are the objects? Right, so these are the things. Yeah, here we have atomic object. I'll visit this concept once again.
Ranjit, last one. So it is one data kind, right?
Yes.
If let us say lab results, if we have two types of like numeric data values and the character, both at a time the data values will come up, right? So that time will it be like if same kind of values are there, it will be a vector.
Correct.
So different type of data type values are there means that time what we call it as.
Yeah. So in R, it is basically it'll do a coercion internally, right? And it basically converts all the data type into a same kind of data type, right? Keeping that in mind, right? There should not be any loss of information, right? So it basically store the data in such a way that there should not be any loss of information, right? And data type must be same if we're creating a vector. For example, I'll come to that point later, but let me just give you one example. So what I am doing here, let me create one variable, maybe X, right?
That's okay. If we are in coming
Yes.
time,
For example, here we have A, then I'm combining B, and then here I'm storing C, third element as 3. Okay, so if I run this, what this does, it will basically convert this 3 into a character data type. So let me show you. I can print this. If you notice, this 3 is converted into a character data type. But if you notice this original, right, I provided C as a number. So it basically does internal coercion. It'll try to convert the data in such a way that there should not be any loss of information, and keeping that all the elements what we have, right, but what we are providing must have a same data type. So the problem here is we cannot convert, right, this alphabets A, alphabets B into a numeric objects, right, because that is not possible. So the only possible route is just to convert this 3 into a character. Okay, and that's why we have. So this is called internal coercion. I'll come to that point later, right? So this is the point.
Thank you.
Yeah. Okay, so then here we have assignment operator. So assignment operator allow us to do kinds of assignment. For example, you are creating multiple name, right? You are combining with the combine operator, but you'll have to store somewhere. And for that, you'll have here assignment operator. You can have left assignment operator, right? You can have a right assignment operator. So what is the difference? So this is a symbol. So in the case of left assignment operator, so symbols all are pointing to the left hand side, right? So this is called local left assignment operator, where we just have a single arrow pointing to the left hand side. When we have two arrows pointing to the left hand side, that is called a global left assignment operator. And then here we have an equal. This is also a part of a left assignment operator. Okay, let me just put all here. Okay, then this is a local global. This is called global left assignment operator. So you can very easily relate with a global variable or a local variable, right? What we generally create in SAS, right? But this is a slightly similar kinds of concept, right? And here we can have the assignment that basically works in a different way. Okay, so let me shift to the right hand side. Okay, so these are the three, basically 4 part, right? We have left assignment. This is called a local left assignment operator. It can also work as a global when we assign right outside the function. So this is the difference. So whenever you are using local assignment operator outside the function, so it will basically store as a global variable, right? Or store as a global operator, right? Okay, let me just put that. Okay. For example, here, so I'm just storing this 4 inside this variable X. Okay. So here, whatever the thing that we have on the right hand side is inserted into the object or a variable name, whatever we have on the X, right, on the left hand side. So once I run, it will basically store 4 here in the variable name X. Okay. So this is the thing you can very easily print. Similarly, we can do a right assignment. Yeah, so whatever the thing that is there in the left hand side is getting inserted the variable name, whatever we have on the right hand side. Okay, so if I run this, it basically holds y is equal to 1, 5 and 7. You can print Yeah, so you can use left assignment operator, you can use a right assignment, there is no problem, but as conventions we generally prefer a left assignment operator, but we can do a right as well. Okay, the next part is here. This is the thing. So whatever the value we have here on the right hand side is getting inserted on the left hand side, right? So here, for example, 3 is inserted or stored in object in the variable name A. Okay, and here I used a global assignment operator. So this is outside the function, so it should not be, there should not be any difference. Okay, because every time, right, it will store here under the global environment. This is important. Here, if you notice, I use with the local assignment operator, local left assignment operator. Here I use a local right assignment operator. Despite that, it is storing here in the global R environment. So this is the difference, right? If you create any objects outside the function, it will basically store as a global in the global environment, right? For example, here, if I use this one also, so this line number 68, line number 72, here I use a global assignment operator, right? And it is already there here in the global environment. But you can very easily identify the difference when I use the function, right? Function is a different class, right? I'll take a function at the later session, but this is just to give you an idea about this local and global operator. So that's why I'm just giving here some demonstration. So what I'm doing, I'm just storing here y1. Okay, so here we have 4, then I can remove that. So now y1 is gone. Now what I'm doing, I'm just defining a function. So for defining a function, you just have to use this function directives, right? Function with parentheses. I'm just creating function without any argument. That's why we don't have anything inside this parentheses. And then here, this is the function body, right? Here I'm defining x1, y1. And if you notice, I'm defining x1 as a global assignment operator. Why? Because I used a double arrow pointing to the left. So this is basically a global left assignment operator. Y1, I'm just specifying with a single local assignment operator, and then I'm evaluating the sum here. Okay, so if I run this, it will basically create a function right here in the function categories, and now I can call the function. Function calling is very simple. You just have to call with the name. So this was the name of this function. So I can specify function name, and then I'll have to use a parenthesis because I have not defined any argument here. So that's why this is function without any argument. So I can specify that parenthesis without anything inside, and I can call. And if you notice, it is basically working. Why? Because this function is basically designed to add x1 and y1. Yeah, so this is okay. 2 plus 3, that is 5. This function is perfectly fine. But the main difference comes when I want to extract this x1 and y1. Okay, so let me extract x1. Yeah, so it can very easily work, right? There is no issue. But when I try to extract y1, it gives an error. And why? Why this is the error? Because here in the function, I define y1 as a local with the local assignment operator. So it can work here in the summation, right? It can very easily it can very easily incorporate, right, its values here in the summation, but outside the function we cannot extract that. Okay, because this is defined locally. So this is the difference. So when I but on the other hand, x1, I defined x1 as a global variable, right, or global with the global assignment operator. So now I can use x1 at any place, but y1 I just have to restrict, right? And here I cannot use y1 outside the function. I can very well use inside the function, right? It is working fine. That's why it is giving 5 here as a summation, but we cannot use outside the function. Okay, so this is the difference. Let me just give you one more example. For example, here, this is another function, myfun1, and this is also for adding 2 number. I can do other operations too, right? There is no issue. And here I'm defining x underscore val, y underscore val, both as a global, right? Global left with a global left assignment operator, right? So whenever you are defining with a global left assignment, you can very easily evaluate the function, and you can also use x and y, right? The input anyway, right? That's why you can very easily give here the values of x and y. Yeah, so this is the difference. Similarly, you can define multiple combinations of these, right? So for example, if you define locally, you can use that inside the function, but outside the function, it does not work. Yeah, you cannot access x1 underscore val2 and y1 underscore val2. Yeah, similarly we can also define global right here this way. So you can notice I'm just defining this y underscore val2 outside the function. So whenever you're defining anything outside the function, this is basically defined globally, right? And you can very easily locate. So once I run this line number 111, so it will have here y underscore val2 as 3. Yeah, because I defined this globally, and I can use this x underscore val2 inside this function, right, with the local assignment operator, and I can very easily use that, right? So what this does, when I run this function, it will basically use the value x underscore val2 from inside this here, right? And then it will search y underscore val2 inside this function. We don't have that value, so what this does, it will go to the global environment, and over there we have this y underscore val2. So it can take y underscore val2 as 3, and it can add these two, and that's why we have here the answer as 5. But the problem is we cannot use this x underscore val2 outside the function, whereas we can use y underscore val2 anywhere. Yeah, so this is the difference. So I'll pause here. Any question on this?
So for the left assignment, we can also use equal to, right, Ranjit?
Yeah.
But we usually use
Left assignment
left.
operator. Yeah, why? Because I just wrote that part here. So because equal to is allowed only at the top level operations, but those I'll show you that in my minute.
Okay, and also y underscore val2 is a variable, and then it is also a vector.
Yeah. This is variable and also vector.
Vector and what about the object?
You can combine this y underscore val2 along with the values, right? That is called object.
Okay, y underscore val2 has a value of 3.
Yeah, whenever you refer that, right, that is you are referring an object. So object means you are combining, you are basically referring these two variable name along with the element together.
Okay.
Yeah.
Okay, thank you.
Okay, perfect. Any follow-up question, anybody? Yeah, so here this equal symbol we generally use for a top level operator, right? For example, if you are using any functions, right, so inside that function you'll have to call, or maybe you have some keywords that is defined, and for that you generally use equal. We can also use equal here in the global assignment operator, right, label, but we generally don't use, right, very often. We prefer less than hyphen, that means single left assignment operator. Okay, because this is right, because of different people's uses that nomenclature, right? So this is adopted as a maybe a consideration. But you can also use equal. But we generally use, right, we mainly use equal for the top level operator. For example, you can create sequence using this colon function, right? This is the thing. For example, I can use 1 colon 8, so it will basically create an increasing sequence starting from 1 to 8 by an increment of 1. You can also create a decreasing sequence. So in that case, you'll have to provide the first number as a bigger and the second number as a smaller number, and in that case it will basically create a decreasing sequence by a decrement of 1. But we can also create a sequence, right, with the other than this colon operator, right? We have the sequence function and it can create a sequence. So you can use sequence 1 colon 50. It will create increasing sequence starting from 1 till end at 50, right, by an increment or by a jump of 1. But whenever I need a jump other than 1 or an increment or decrement other than 1, so we'll have to specify explicitly, right? So we'll have to specify from is equal to 1, this is starting position, 2 is equal to 50, this is end position, and then here I have to use by. So by is basically a jump or an increment or a decrement, right? So whenever we have the first number as smaller, second number as bigger, So in that case, it will basically create a increasing sequence, right, by an increment of 4. So you can do that. Sometimes we'll have to create a decreasing sequence. So and other than a jump of 1, right? So for example, here in case of decreasing sequence, I'll have to specify a bigger number as a starting position and smaller number as an end position, right? And then I can specify by as a -4. So in that case, it will basically create a decreasing sequence starting from 50 till 1, ending at 1, right? And by a decrement of 1. So you can very easily verify that. Okay, so this is the way how we can create increasing and decreasing, and you can use other number too, right? Here you can use 2. Okay, so whenever you are trying to create a decreasing sequence, you'll have to always use bigger number here, smaller number at the end, right? And by, right? So you'll have to specify with the negative symbol, right? So this is the thing that we have to keep in mind. Then again here, this is again another example. Okay. So sometimes if you want to explore a certain functions more, so what you can do, you can invoke the help window, right? You can invoke a help functionality of R. So you'll have to just use a question mark before that function name. Suppose I don't know mean and I want to see what are the arguments that we have to specify. So you can use question mark mean and it will basically open here under the help window, right? So that's why this window is very useful, right? It will give here mean. This is a part of a base R. Okay, here we have a description. Okay, then here we have various uses, their arguments, right? And we'll define each arguments one by one. And at the very end, we'll have some example. Okay, so you can use that. Similarly, you can check some function, or this is another way, right? Or the second way is you can use help, and inside that you can use the function name, right? This will also invoke the help window, right? So it will again open the same thing, right? And you can very easily locate. Okay, why am I using this help here? Because I'll show you the functionality of mean, right? For example, here, what I want. So if you notice, in the case of mean, we just have a single argument x, right? And here we'll have to use a numeric vector, right? You can very easily get an idea. So Rx, this is R an object. Currently, there are methods for numeric and logical operators, dates, the complex. Yeah. So this is the thing. And here, if you notice, we'll have to provide x as a numeric vector. Yeah. So now I'll use a numeric vector 1 colon 5. So what I want to do, I want to evaluate the mean from number 1 to 5. Okay. So I can use x is equal to 1 colon 5. So if I run this, it can very easily work. Right here, we have mean as 3. Okay. There is no issue. But when I run this one, so here if you notice, I'm just defining with this left and hyphen left assignment operator. So what this does, it will evaluate the mean of first 5 number, and also it will create a vector x, right? So right now here, if you notice, we have x is equal to 4. So it will basically replace that. So once I run this, you notice it is replaced here. Yeah, and it is replaced with the number 1 to 5. And it also evaluated the mean. So this is the difference. So that's why at the top level programming, right? So we generally don't use this assignment, okay? Because we generally don't want any kinds of assignment, right? So that is the main part, okay? So that's why over there we generally use equal symbol for specification of means, okay? Any question? Yeah, so there are 2 other symbols. For example, sometimes we'll have to do a filter application, right? We'll have to apply filter on safety population or PP population or ITT population. So over there, we just have to use 2 equal symbols. So 2 equal symbol is not assignment. This is basically an evaluation. Why I'm covering here? Because these 2 are similar. So sometimes people maybe feels that these are same, right? But these are not. So whenever you are applying filter, right, you are filtering the data sets. In that case, you'll have to use 2 equality, and then you'll have to apply a filter. This is called evaluation. And whenever you are creating a new variable, for example, I'll show you the mutate functionality. This is a part of a deplar package, right? I'll show you, and over there we'll have to use an equal symbol, not a less than hyphen or a left assignment operator, right? Because this is again a part of a top level program. Okay, we can also do assignment with this assign function, right? For example, I want to store 8 with the variable name C. So what I can do, I can use assign, and then I can specify maybe a quotation. You can use single quotation or double quotation. You can specify the variable name first, and then you can specify the values, right? I want to store this 8 as a numeric, so that's why I'm not specifying any quotation, right? So it will basically store C as 8, right? And you can very easily see here in the console. Okay, you can also store multiple elements, right? This is again same thing. Yeah, you can also store names, right? So here this is a variable name and these are the elements I want to store, right? Basically these are the names, so we anyhow need to specify either single quotation or double quotation, right? So this is the thing. I will let's have names where we have all the names. Okay, so you can use assign, but people generally don't use this assign operator because this is you just have to write 5-6 text, right? And then we'll have to use quotations, right, parentheses. So that's why it is always a good idea just to use a less than hyphen or left assignment operator for assigning any objects in R, right? But because we are covering everything, right, so that's why I just want to give this function as an example here. Okay, so any question on the assignment part? Anybody? Okay, so now I'll show you the evaluation.
Sir, I have one question.
Please.
Sir, in this assignment, we are assigning like with assign nomenclature. How to put in a in a vector like X, and how to create a object
with multiple element, right?
No. We are writing assign as a word, like
yeah, so
assign
here,
instead of left
here,
assign.
Yeah, here we are creating. This is the this is the vector name. Yeah, no. So this is a vector name,
okay,
and here we have the elements.
Yeah. Oh yeah, I missed that. Yeah.
No,
okay. Thank you.
No worries. Okay, so let me create again, and I'll show you some other examples. So, for example, I can create here this left assignment operator, and I can print with this just same thing, right? So whatever thing that you store, right, you can just use and you can run with the control enter or run button and it will print. And that is called auto printing. You can use explicit print function for printing that same thing, right? This is the same, there is no difference, but one is called auto printing because here we are not using any function, whereas the line number 162 here I am using this print function. That's why this is called explicit printing. Why this is important? Because we generally don't use this print every time, right? You can just use the object name and it will basically print all the things in the console. Okay, the next function is paste. What this function does, it will basically combine 2 or more than 2 string, right? So you can have paste 0 and we also have paste. So paste 0 basically combine the text without any separator. Okay, but paste function has a functionality of separator, so you can specify separator here and it will basically combine these two with the separator, right, as a slash. Okay, but here we don't have any kinds of separators, so we generally it will basically combine without any separator. But if you want to put separators, you can specify as additional text or additional character or string, right? So here I'm combining clinical and R with additional space right in between, so I'm just specifying explicitly, right, and it is basically adding these two. Okay, so whenever we just have to, so sometimes we'll have to store some values. For example, I want to print X, right, and I'll have to also specify some meaningful name, right, as a dummy name, right? So what I can do, I can combine the paste 0 function, right, and here this is the dummy text value of X, and then I'm specifying the X here. So what this does, it will basically combine and it will print here in a nice form, right? Value of X colon 4. So what it is doing, it is combining this dummy text and it is also pulling the value of X from the vector that right. this x holds, right? So x basically holds this 4, so that's why it is pulling from here and is combining those two things together. Similarly, we can run this character vector I'm creating here. I can print, yeah, I can again create integer sequence starting from 10 to 28. We can do anything. Yeah, this will create increases sequence by increment of 1 right here. This is again another example. You can check the structure. Yeah, then this is the two important functions, letters and late. So one is in lowercase and the other is in uppercase. What this does, this is basically built-in function in R. It will basically create alphabetical sequence, okay, starting from A to Z in lowercase. If you use this function in lowercase, right, so it will create in alphabets A to Z in lowercase. If you use this one, it will create alphabets from A to Z in uppercase. Yeah, so let me run this. Here we have, then again here A to Z in uppercase. Yeah, so these are the functions. We can use these functions, built-in function, and we can very easily do the subsetting. For example, I want to extract the first 10 alphabets from these letters. So what I can do, I can use letters and then I can specify big bracket 1:10. So it will basically extract a first 10 element from that letters. Yeah, here we have from A to Z. Okay, so these are called evaluations. So we'll cover the other part, right, as we proceed, but this is just a glimpse. Okay, any question on this evaluation part, anybody? No question? Okay, then this is very important, R objects. So basically R has 5 types of atomic class or object, right? These are very essential, okay, for storing any kinds of data types. So you can have character class, right, character atomic object. You can have integer, you can have a numeric, right, that's stored with double precision. Then we have a logical operator, right, that holds the values in the form of true and false. And then fifth is a complex that holds the values as a complex. So if you recall in this in the school, right, school days, over there we generally have to study a real number where we have an imaginary part and some real part. Okay, so that is called complex number. Sometimes we have imaginary part, sometimes we have real part, right? So if we combine these two together, that is called complex, right? So for handling those kinds of data, we have here that object that is called complex. In clinical trial settings, we generally don't use this, right? But I'll cover that part, just a glimpse. Okay, so first atomic class or atomic object is called a character, right? So you just have to use you'll have to, if you're defining any character, you'll have to use either single quotation or double quotation, right? So we already seen, right, with a name, and this is called a character. You can just check the structure with the str function, right? And here whenever you want to store a multiple character together, you'll have to use a combine operator C. Okay, and here we have. Then you can explicitly check the class using the class function, right? It will give a class here. Similarly, we can use mod function. It can also give the same answer, character. Yeah, so for checking atomic class, we generally use class or mod function, but the same thing we can also check using str function, right? The second atomic class is numeric or real number, right? This basically holds with a double precision. What this means, so sometimes we need to do mathematical evaluations, and for that we need to preserve a certain decimal component of a number, because if you just not use a proper decimal component, right, you'll not get the accurate answer. That is called a precision, basically. Okay, so real number basically stores all the numbers with a double precision, right? And that means it basically have some, for example, here I'm storing x is equal to 3, right? That means this 3 is not just 3, it also have some decimal components. So in this case we are not having any decimal components, that's why it will basically store as 00, right? But sometimes if you want to multiply with some other number that have a decimal component, right? So to get an accurate answer, we also have to have this x as or with a double precision, right? That this means, right? That is this real number mean. Okay, so if I check the structure, sorry, a class of this whole thing, right? This give numeric. If I check the structure, this is again a numeric. But if I check the mod, this is also numeric. If I check type of, so this is the double, right? And that means it will hold this number 3 with a double precision. Why? Because this is an efficient way of storing real number, so that will not have any loss of precision. Okay, if you multiply with some other number. Okay, then the third is integer. So whenever we specify capital L right after the number, that holds the number as a integer, right? So here we don't have a scope of any decimal component, right? And here we just have 4. If I check the class, integer, mod, integer, and type of, again integer. Yeah, so here it is not giving as a double. Why? Because I store as a integer, and integer does not have the decimal component. Okay, so we have differences. One is numeric, that is real number that's stored with a precision, double precision. Okay, when I specify capital L after the number, right, that stores as an integer, and over there we don't have the decimal component. Okay, the fourth is a logical operator. This is very simple. Logical gate, right? You can remember the physics concept, right? You'll have either true or false. Okay, so if you want to store anything as a logical, right, whether something is true or something is false, right, so you can store that, and that is called a logical atomic object, right? And here we have to be very careful. Whenever you're using true and false, you'll have to use always a uppercase. Okay, for example, here I'm storing a false. Yeah, I can check the class mod. I can store true as well. This is logical, but we cannot use this true and false inside the quotation. If we use quotations, whether it is single or double quotation, it is no more a logical, right? It is basically converted as a character data. So this is the difference. So you cannot use quotation. You cannot use this as giving character. This is not logical. You cannot also use a lowercase. Yeah. So this is again a character. So whenever you're storing a logical data type, you'll also always have to use uppercase without quotation. Okay, so that is a logical atomic object. Then we can also use complex. This is special, right? Because this is just to handle the real analysis aspects, basically a mathematical aspects, but we generally don't use, right, these very often. In case of statistical modeling, the models basically use internal structure as a logic complex, right? Because sometimes we'll have an imaginary part, right? And but we don't have to worry, because the model automatically solve for us, right? But the structure is very simple. Complex is a number where we have a real part and also the imaginary part. So the one where we have I is called iota. Okay, and the value of iota is square root of -1. Okay, why -1? Because sometimes if a negative number, you cannot get a square root quantitatively, right? You'll get on the imaginary axis. That's why this complex number is defined. Okay, so that is a concept. And here we'll have to have 3 plus 4i or anything, right? So any number that have iota or I, that is called complex, right? And here we can check the class and mod. This is a complex. Okay, so we have total how many objects? We have 5 objects. First is character, then we have numeric with real precision, then we have integer, then logical, and then complex, right? Here I'll show you the data type. So data type is basically a classification of this atomic R objects in such a way so that we can perform we can get an idea which type of mathematical operation or relational operations or logical operation we can perform, right, without having any error. So for example, here we have 4 types of data. One is character, then we'll have to combine the numeric with real precision, right, and double precision, and then integer together, right? So that is second data type. Third is logical, and fourth is complex. So you can very easily get an idea from here. So what I'm doing, this is a separate data type, character, then I'm combining this numeric and integer, real and integer together. Yeah, so this is Data type 2, data type 3 is logical, and data type 4 is complex. So here we have the same thing. That the first is character. This is again same thing. Second is number, right? That may have a real number with double precision, or integer where we don't have decimal component, right? Whenever you are defining anything in a real anything with a real number as a real number, you don't have to use capital L at the end. Whenever you are defining anything as an integer, you'll have to write capital L at the end. So capital L is a distinguisher, right? So if you specify any number with capital L, that is integer, not a real number. Okay, so this is the thing, and you can very easily so let me run this one by one. So this is very similar kind of concept. So here we can define a single L. This is integer. You can use, right? So if I check the class 2 plus 2, if you notice here we don't have L, so it'll have a numeric class. Okay, similarly if we define 2 plus 2L, so this number has integer component, this number has double precision, right? So we'll have basically total as a numeric, right? Similarly, if we check the class of this whole thing, that 2 plus 2L, right? If I check the type of, so it will provide as a double. Why? Because one number is with integer, right? The other number is with a double precision. That's why if you combine the one number with a double precision, the other number is just a numeric, right? Just an integer. So in that case, the combined number that we'll get, right, after the addition, that must have a double, right? So this is the way, because otherwise it will basically lost the decimal component that we have in the other number. Okay, so this is the difference. And then here we can store the real number. If you don't have capital L at the end, right, that is basically a real number, and you can check the type and mod. Similarly, logical operator you can just define with capital T, right, or capital F. So this is also a way, right, for defining a logical data type. But you should not have to define in a running case, and you should not keep that true and false inside the quotation. Okay, this will not work. This will give an error. Okay, because there is nothing. If you want to define this true as a character, so you'll have to use quotation. Otherwise, it will give an error. This is also given an error, right? Because there is we cannot define this false in this way. You'll have to use always a capital letter, or you can use capital T or capital F. This is acceptable. So let me add that one here. So this is acceptable. This will work. There's no issue. This is also okay. Yeah, the ideal way is just write a full text, true or false in uppercase. Yeah, but we cannot use this running case. This does not recognize. Okay, similarly complex, I already gave an example where we have some real part and imaginary part. Okay, so now I'll pause. Any question, anybody on this atomic objects and data type?
So Ranjit, you talked about the iota, right?
Mm-hmm.
So like to calculate minus, to handle the minus,
correct,
or like in general we'll use in the day calculation, right?
Mm-hmm. Correct. You're right.
Okay.
So this is just a presentations, right? So this is just a representation. If you ask me, right? So we generally create a imaginary axis, right? And over there we'll represent all the values. For example, here we have 3 plus 7. Yeah. So this is a part of real axis, and this is a part of imaginary axis. Okay, because we cannot get the square root of negative number. So that is the maybe a structural way of representing, but there are a whole lot of different domain of mathematics is established, right? Let's go real analysis, and over there we generally use this concept very regularly. Yeah, because this R is very general language for all the people. That's why these objects are defined just to accommodate. Right, so if you can compare with the other programming language, right? So here we have 5 type of atomic objects. That means you can store 5 type of objects, right? Here, but most of the programming language just have 2 structure. One is numeric and the other is character. But here we have. Okay, any follow-up question, anybody?
So where do we use the numeric value with L, and then just the real number.
Yeah. So suppose you want to create maybe a patient ID, right? So patient ID does not have a fraction, right, or decimal component. So what you can do, you can define number with capital N, but sometimes you'll have to define weight or BMI that may have decimal component, right? So then you'll define without capital L. Okay.
Okay.
Yeah.
Got it.
Ideally, in the clinical trial settings, we generally don't have to use this structure because we'll get the data, right? And we just have to import and then we'll have to work, right? But whenever you're defining BMI, we just try to define without capital L because it may have a decimal component. But whenever you are defining patient ID, right, or subject ID or anything that does not contain a decimal component, that does not have possibility of decimals, right? So in that case, we'll have to use capital L at the end just to define the values in terms of integer. Yeah.
Okay. Thank you.
Perfect. Okay. Any last minute question, thoughts before I move to the next part? Okay. So here I gave an example of coercion, right? I'll revisit that example tomorrow, right? So whenever we try to combine two different data type together, right? Two or more than two data type together. So R basically try to accommodate the values without losing precision, right? So it basically store. So, and the rule is, I'll give you a complete rule tomorrow. So rule is whenever we have a character is one of the element of the whole list, it try to convert all the other objects, right, or the other element, right, of maybe of a different data type. For example, it can have numeric data type, it may have a character data type. So it try to convert all other into a character because there is no way we cannot convert a into a number. So there is only possible route, and that is just to convert this two into a character data type. Yeah, this is just a glimpse. I'll give you the other example tomorrow. Okay, and numbers in R are generally treated as a numeric object with a double precision, right? So whenever you specify, so here this is again an example. So whenever we don't have capital L at the end, right, it will store as a double precision. Okay, whenever we put a suffix as capital L, so these are a integer where we don't have a decimal components. And here comes the maybe a more advanced feature. So if we divide any number by 0, we'll get 0. Sorry, if you divide any number by infinity, 0, you'll get infinity. So this is the term that we don't have in other programming language. We don't have a defined term for this plus infinity. Okay, if we define 1 by infinity, so we'll get a value that is close to 0, so it will give a value as 0. Okay, so these two are very special thing, right, we have in R. Okay, we have a defined term for infinity, and we also have a defined term for 1 upon infinity, that is 0. And again, this is the very important thing. So in calculus, whenever we get any term in the form of 0 by 0, that is called indeterminate form. That means you cannot deduce that things further. Okay, so the thing is, here we have a defined term for that, right? So 0 by 0, whenever we have, so it will basically indicate as a NaN, and NaN is short notation for not a number. Okay, so we have defined, and that is the main difference with other programming languages. This combine operator, this allows us to combine multiple elements together, right? And here we have. Okay, so we can very easily extract. For example, I want to extract a first element. Let me just remove that so that I can run this first one. I'll show you how to extract. Suppose I want to extract this alphabets A. So A is at the first position. So what I have to do, I just have to specify this vector name or object name, right? And I can just write big bracket 1, and I can extract the first element A. Suppose I want to extract the third element, so I can just write here 3, and in that case it will give ABC. Yeah, and the point here is the class of this original element and class of the subsetted element must be same in case of a vector. So that means here, if you notice, this is a class of this original object X, original vector x, right? And here this is a class of this substituted element. Maybe we can have 1, 2, 3, whatever, right? Both must have the same class, right? And that is the property of any vector, right? We can also check here. So a is also a numeric vector, right? The structure of this a is integer, right? And I just extracted this third element here. So third element is 4, right? You can notice a, where it is a, yeah, here 1, 2, 4, 6. So this parent vector is integer, and the subset also have the same data type. This is also integer. Okay, so this is the main part. Similarly, we can create a vector with the combine operator. I already created a whole lot of example, right? At the top here, these are another example, right? But I'll show you here. We can also create a vector with this vector keyword, right? Or vector function. So what we have to do, we just have to use a vector. Then you can specify the data type, whether you want to create a character vector or a numeric vector or anything. You can just write here, and then you'll have to specify the length, right? How many character vector, how many, what are the lengths that you want to create here, right? So you can specify length as 10. So it will basically create a dummy vector, okay, of character data type of length 10. And in case of dummy vector, it will basically store nothing, right? It will basically have quotations, nothing inside. But if you create a numeric vector, in that case, it will have 0. Yeah. So these are the thing. And here, these are another example. You can run this and you can check. This is the way of extracting different element right here. And then I just, yeah. So let me show you this one. So what I'm doing, I'm just creating B. And if you notice, I'm store a B as I store here 2 values, 1 and 2. And if you notice, these are in character data type. Okay. So suppose I want to convert into numeric. So how we can do? We have an explicit function as .numeric. So it will convert that into a numeric data type. So let me show you. Yeah, 1 and 2. This is numeric, and now I can store it with the valid variable name. So I'm just reusing b underscore num because this is now a numeric object. And I can check the structure. This is num. Yeah, and then we can do other thing. Okay. Similarly here,
Sir,
yeah, please.
Sir, I have a question.
Please.
So let's say 1 is a character and 2 is numeric. Then how implicitly it convert into numeric or a character?
Yeah, so it will convert. Yeah, so here by default it will have character structure, right? You can notice here.
Okay.
Yes, this is character because it'll do the conversion, right? It will convert this 2 into character. Yeah.
Character.
Yeah, and then we can use as .numeric, the same function, and we'll convert that into a numeric.
Okay.
Yeah. Here also we have one more example. For example, I'm combining here alphabets A, 1, 2, and 3 plus 2. So if you notice, we have one character. So what this does, it will try to convert all 3 elements that is not character, right, into a character data type. Because there is no way we cannot convert this alphabets A into numeric or logical or complex data type. So there is only one route, and that is just to convert all 3 elements into a character data type, and that is called this implicit coercion, right? So because we are not using any function, it is doing implicitly. Okay. Similarly here, for example, I can combine the so let me just do this way. Yeah, this is okay. So when I combine Anil with Anil is as this is character, this is very clear, right? And here I'm also combining number 1, right, into a character data type. So there is no problem. So if I check the structure of this Y, this is character, there is no issue. But if I create the second one Y here, so I'm just storing 2, then Anil, this is character, and then again 1. So we have 2 element that is numeric data type, right, with double precision, and 1 is character. But when you combine this way, right, what this does, it will basically do an implicit coercion, because there is no way to convert this Anil into a number, right? So it will convert 2 and 1 into a character data type. Yeah, and because we are not using any function for that conversions, that's why it is called implicit conversion. Here I use as dot numeric. That means I use explicit function, right, for converting that. So this is example of explicit conversion. Okay, and this implicit coercion is inherent property of R. Why? Because it don't want to lose any kinds of data, right? It want to it basically try to maintain the data structuring, okay, without losing any kinds of precision. Okay, so again here another kind of object that is called list. I'll cover that list in very much detail tomorrow, right? This is a special kind of object in R that can store a multiple type of data type together. Okay, so for example here, if you notice, we have 1 colon 3, that means an integer from 1 to 3. Then here we have a decimal component. Then again here we have two values separately, right? So I store capital 10L, 4L, these are integer numbers stored separately. Then I store alphabets Anil, right? Name Anil and Naidu, right? So here we have different, these are integer, then here value with double precision, then here these two are integer, then we have these two as a character. So the speciality of list, it can accommodate a different type of R objects together. And this is the structure. So you can think of a list as a compartment, right? It can have a almirah, right? And inside that almirah we have a compartment. Let me just let me show you. Let me take a screenshot for a blank page so that I can annotate. Yeah, so so here you can think of almirah. How many compartments we have? We have 6 compartments. You can segregate that. 2, 3, 4, 5, and maybe we can have 6 here. So I can just write name 1, 2, 3, 4, 5, and 6. Okay. So compartment number 1, how many elements we have? So inside the compartment we have different cells. So you can have cells. And first cell is stored number 1, second cell is stored number 2, third cell is stored number 3. Okay, so here we have. So you can notice this part. Then again, compartment 2 have two number 1.2 and 1.3. So you can split this compartment in 2 parts, 1.2 and 1.3. Similarly, compartment number 3 that have just a single values 10. And if you recall, 10 was stored as a with the capital L. That means this is a integer value. So anyhow, we can just write 10. Then after that, fourth is just a 4. Then again, Anil. Here we have Anil. Sorry, I'm writing with the mouse. And then fourth is an Naidu. Okay, so this is the structure of list. So we can think of almirah. Inside that we have a different cells, and each compartment, right, stores a so whatever the thing that we specify. For example, here, if you notice, I combine these things together. Here I combine these two. So that means I want to store these 1.2 and 1.3 inside a single compartment. So it will go in that compartment. It will basically split in 2 parts and will store 1.2 and 1.3. Then 10 I have not combined with any other number, so it will basically holds as a separate entities. Okay, so this is the main part. I'll cover that part list tomorrow. So I'll pause here. Any question, anybody?
Ranjit, so C of 1.2 comma 1.3, what does that C represent?
C is a combine operator, Anvita. So we are combining 1.2 and 1.3 together inside that list. That means it will basically go there in a specific compartment. Okay, these two numbers store together inside a compartment. Okay. Yeah. Similarly,
thank you.
No, nice. Okay, please. Yes, Gitanjali.
Can we create one data frame from this list? Like we are creating object inside it. One is to one.
I'll come to that data frame in a minute, because data frame is maybe a higher object. So that's why first I just want to cover a list, right? So list is object that can hold a multiple type of data type. The difference is the structure, right? So here we have a compartment type of structure. You can have a big container. Inside that we have a different separator, right? And inside that, right, inside the particular separator, you'll have a different cells. Okay, and this is the way how
So list
stores values. Yeah.
So my question is, list can be used for creating the data frame?
No. We can use that, but in a different way. These two are two different concepts. So earlier, before development of a data frame as a concept, right? So people try to handle this list, right? At least nowadays, nobody use, right? Because this has a very complex structure, right? For example, if you want to maybe extract some number from a list, you'll have to use double quotation, double a big bracket, and then so that's why people prefer a data frame, because if you have a data frame, you can very easily process the data. This is one advantage, and also the extracting and working with this data frame is efficient as compared to the list. Okay, so that's why I don't want to miss the list. That's why I'm covering. But anyhow, we will not use list very often in the real programming.
Okay.
Yeah.
Thank you.
Okay, so here I again define another list, right? And here, if you notice, I define this V1 and V2, right? I can combine these two and I can create a data frame using the data.frame functionality. So this is called a data set. And in R, we call a data frame. So here we have columns and these are the rows. These rows represents the observation number. Okay. Then comes the attributes. So yeah, please.
One small question. Yeah.
Sure, please.
If we combine the two vectors with a different length, is it possible to combine?
No, so you cannot combine. You will have to accommodate. You'll have to make the length same. What you can do, you can accommodate or you can add NAs right in the first vector or second vector, and then you can combine. I'll show you later how we can combine using this deploy nomenclature. But for now, maybe you can remember that we cannot combine when two vectors have a different length.
Okay.
Yeah. So that's why I define this V1 and V2 strategically with length 10, right? So we can define, and then next part is attributes. Attributes is nothing but the metadata about any R objects. So you can extract the names, you can extract column names. There are a whole lot of things, right? So name is a function that extracts the variable name, right? V1 and V2, these were the variable. You can also use call names. This gives the same answer. Then dimension name will provide the dimension of the data frame D. So here, if you notice, we have 1 to 10. This is a number of observations. And the second part, this is giving information about the variable name. So V1 and V2 was the variable. Then you can also extract the class. This is again a data frame, right? You can extract the class of a C. C is atomic object I define as a numeric, right? You can extract the class for any, right? I already covered. Sometimes we also have to have label defined for a particular object. If you have a label defined, you can extract that using this label function. You can also define comments and you can extract with the comment function, right? I have not defined, that's why it is giving null. Then dimension. What is dimension? That it basically extract the number of rows and number of column of a data frame. So first value, this represents the number of rows. That means number of observation that a particular data frame has. And second value is for the column, that means number of variables. Okay.
I just hi Ranjit.
Hi, Ranjit.
Hello, can you hear me?
Now we can hear you.
Since 10 minutes we can't hear you actually.
14 minutes.
Yeah, 5 minutes. Since 5 minutes we are like we can't hear your voice.
Okay. Oh, sorry.
We are pinging and we are raising hands.
So I cannot see the hands here. Yeah, sorry for that. I don't know why. What has happened? Okay, no worries. I can just repeat that part once again. Okay, give me a second. I'll just cover that. Let me cover. Okay. So here, did I cover this attribute, or should I cover this attributes, or is this completed? Right? Anybody?
I mean, till dimensions and length, I think. Yeah.
Okay. Dimension and length, right? So after that, here we can also extract this attribute function. So attribute is a general function that is defined in R, right? Using that, we can very easily extract the metadata information. So if we use attributes on a higher level objects, right, you can get a meaningful value. So for example, I'm just using attributes on D. D is nothing but this data frame that I define here, right? So if I run this, it'll give here a meaningful values. Names, these are the variable name defined right inside this data frame D. Then we have class. Class is a data frame because this is a data frame objects, right? And then we have values 1 to 10. So these are the number of observation that D has. So sometimes people also use attribute function on atomic objects, and that is not advisable. Why? Because it will not give a meaningful values. Why? So let me just run this. N is equal to 1:3. So this is an integer objects I defined, and if I run this attribute function on top of that, it will not give any meaningful values, right? So attribute functions returns NA if we run on top of atomic R objects. Okay, so attribute function is useful whenever we have a higher level of object, for example, data frame or matrix, okay, or arrays. So in that case, this attribute function is useful. In case of atomic R, you can use either class or str or type of objects for extracting the data type, right? So these are the things I just want to cover. I'll pause here. Any question, anybody?
Sir, what do these levels means? Like,
yeah, so you can define labels. For example, when you define ADSL datasets, you'll also have to define the label as subject, one subject per record, right? Similarly, for example, in the case of ADLB, we'll have to write laboratory data. Okay, so that is called label of a particular variable. You can define that using this label function. So if you have a label defined for particular objects, you can extract, otherwise it will give null.
Okay. For numeric, it will be null always.
Yeah.
Thank you.
Okay, and then here, any last minute question, thoughts, anybody? So don't hesitate. This is your class. I'm here just to help, right? Yeah, Riaz, please.
No, I don't have any.
Okay. So I recommend everyone, if you have any questions, every question is a valid question, right? So don't hesitate. And yeah. And I also recommend just do a little practice so that you can remember the past, okay? Because this all are related. We are just building, right? And after maybe 22, 24 classes, we'll do the case study where we'll utilize this functionality. Okay, not all, we'll utilize some functionality in the real case study. And the next part is how to download. Yeah, please.
Yeah, level we are getting the label for character data, right? It's not for numeric.
Correct.
What if we have age and like if we want to get just we know the label, but in case if we want to get the label for the numeric variable.
Yeah, it'll give error. Yeah, it'll give error. So label is only defined for character objects. Yeah.
It won't give for numeric. How to handle that?
Sorry?
How we are going to handle that situation?
Which situation?
Let us say in a data set we have a numeric variables and we want to know what is the label for that particular variable.
Yeah.
How we are going to.
So we generally don't define labels, right, for our numeric data, right? Because label is just to give an idea about what we have in that, right? So I guess we can just define labels. Yeah, you can just define labels. For example, here, suppose I want to give X here label as this subject number. Somebody is, I guess, speaking. Yeah, please go ahead.
Yeah, Ranjit, like I think the doubt here is like in general for all the variables we need the variable labels, right?
Yeah, that is different. That is yeah. Oh, that
yeah,
is
the confusion
okay.
is here.
That is different. That is different. Yeah. So for that we can define one vector and we can specify that label, right? We have a function HMIS package, right? That have a function up data, so you can specify the label in one go. So I'll cover that part in ADSL, right? I don't know why this is not working here. This is not the function. We just have to use, I guess, label without S, I guess. Or I guess I'm missing the structure. Oh, no, this is not working. I'll show you that part right later using this. Okay, so let me just write this way. But we'll have to specify also the object. So this is not. We don't have anything. So let me use this way. No, I'll check that. I'll check and show you later. Okay. And the next part is I showed here how to download the books, right? So you just have to copy this book name. All right. You also find this book on the SharePoint. Yeah, you just have to go in the Google and you just have to type libgen. This is basically a URL, okay, where you can find books free of cost. You can just paste here the link, the book title, right? You can also find all the research paper, right, using this website, right? And you just have to use any one of them, right? Here we have this. This is a PDF format. This is AW3. This is again PDF. So try to use the PDF one. So I'll just go with this first one. Then you can click here on the top. Then get, and it will basically download it, right? So I don't want to download again because I already have. Okay, so you can try downloading the book, right? We already have in the SharePoint. You can either download and you can just look that at the SharePoint, right? You can download from the SharePoint as well. Okay, so that's all for the day. I'll pause for any last minute question thoughts. No question? Okay, if you don't have any question, maybe we can stop the class and we'll continue tomorrow. And tomorrow I'll show you some other feature of R. Okay, so thank you everyone. Thank you for your time. Bye. Have a nice day.
Thanks.
Bye. Bye. Bye.
Thank you.
Thank you. Bye.
Bye. Bye.